Lesson: Deep dive into language models, architecture, and evolution. The evolution of language models represents one of the most transformative advancements in artificial intelligence, impacting numerous domains from natural language processing to automated content creation. Understanding the architecture and evolution of these models not only provides insight into their capabilities, but also equips professionals with the tools needed to leverage these technologies effectively. This lesson will delve into the intricacies of language model architectures, exploring how they have evolved and offering actionable insights on utilizing these models in practical scenarios. Language models have transitioned from simple statistical methods to highly sophisticated algorithms capable of generating human-like text. The inception of language modeling can be traced back to n-gram models, which predict the probability of a word based on its previous words. Although effective for small-scale applications, n-gram models were limited by their inability to capture long-range dependencies due to their reliance on fixed-sized context windows. The introduction of neural networks, particularly the recurrent neural networks, marked a significant leap forward. RNNs, with their ability to process sequences of variable lengths, addressed some limitations of n-gram models. However, they suffered from vanishing gradient problems, which limited their ability to learn long-term dependencies. The evolution continued with the advent of long short-term memory networks and gated recurrent units, which introduced gates to regulate the flow of information, thus mitigating the vanishing gradient problem. Despite these improvements, training RNNs remained computationally expensive and time-consuming. The transformer architecture, introduced by Vaswani et al., revolutionized language models by replacing recurrence with self-attention mechanisms. This architecture enabled models to process words in parallel, significantly improving training efficiency and performance on various NLP tasks. Transformers became the foundation for more advanced models, such as BERT and GPT. BERT, developed by Devlin et al., introduced bidirectional training, allowing the model to consider context from both directions, thereby enhancing its understanding of word semantics. BERT's pre-training on large corpora, followed by fine-tuning on specific tasks, set a new benchmark for performance in NLP. Conversely, GPT, developed by OpenAI, focuses on unidirectional modeling, which excels in text generation tasks. The GPT series, with models like GPT-2 and GPT-3, demonstrated the potential of scaling language models to billions of parameters, improving their ability to generate coherent and contextually relevant text. These models have been instrumental in various applications, including automated content creation, chatbots, and virtual assistants. To harness the full potential of these language models, professionals need practical tools and frameworks. Hugging Face's Transformers library is a vital resource, providing pre-trained models that can be easily integrated into applications. This library supports a wide range of models, including BERT, GPT, and T5, and offers an intuitive API for training and deploying models. By utilizing this framework, professionals can quickly prototype and deploy AI solutions without requiring extensive computational resources or expertise in deep learning. Another essential tool is TensorFlow, an open-source machine learning framework that supports the development of custom language models. TensorFlow's Keras API simplifies the process of building and training neural networks, allowing professionals to experiment with different architectures and hyperparameters. This flexibility enables the creation of tailored solutions that address specific real-world challenges, such as sentiment analysis, translation, or summarization. Case studies further illustrate the practical applications of language models. For instance, financial institutions have leveraged BERT for sentiment analysis on social media to predict market trends. By fine-tuning BERT on financial data, these institutions can gauge public sentiment and make informed investment decisions, showcasing the model's ability to adapt to domain-specific tasks. Similarly, GPT-3 has been used to develop creative writing tools that assist authors in generating content ideas, enhancing productivity and creativity in the writing process. Despite their capabilities, language models also pose challenges, particularly regarding ethical considerations and biases. The training data for these models often contains societal biases, which can lead to biased outputs. Addressing these issues requires a multifaceted approach, including careful curation of training data and the implementation of bias detection and mitigation techniques. Organizations like OpenAI have been at the forefront of developing guidelines and tools to minimize bias in AI systems, ensuring that language models are deployed responsibly. In conclusion, the evolution of language models from engrams to transformers represents a paradigm shift in AI, enabling machines to understand and generate human language with unprecedented accuracy. By leveraging tools like Hugging Face's Transformers library and TensorFlow, professionals can harness the power of these models to solve complex real-world problems. However, the ethical deployment of language models remains a critical consideration, necessitating ongoing efforts to address biases and ensure fairness. As language models continue to evolve, they will undoubtedly play an increasingly integral role across various industries, shaping the future of AI and human-computer interaction.